Hey guys, and welcome back to another A-level maths video. Now, I know you're already thinking, equation of a line, really? But I promise you there are some actually pretty tricky things in this. Not just that, but as usual, you know the drill, it leads on to further topics in A-level maths and even A-level physics. We need to be able to use the equation of a line, but also do something called coordinate geometry. So a lot of the times when students struggle with a certain question in A-level maths, we're going to get onto those in a bit, they wonder what topic it is, because there's actually a lot of geometry. You're going to be calculating areas of triangles. And I know what you're thinking, equation of a line, coordinate geometry, really? And the answer is absolutely yeah. So it does get a bit strange, it does get a bit more advanced. So I'd recommend at least downloading the worksheet if you think it's a bit too easy, going through it and seeing how far you get. However, the actual skills are very similar to what we had in GCSE, it's just different styles of question. That being said, as always, a link in the description. Links to the Patreon, which has the worksheet, which you can download and just complete at your own leisure. Use this as a mark scheme. And there is also a link to the A-level maths playlist that I made last year, which had live stream lessons for a bunch of the topics, okay, going for a couple of months. But without further ado, let's jump straight into the questions. So, probably a fairly standard question that you've seen on a GCSE maths paper before. However, believe me, this was actually an A-level maths question. The line L passes through the coordinates 2, 1 and 4, minus 5. Find an equation for L. Now, in these questions, I will start to just draw little diagrams. Now, for this particular question, it's not really necessary, if I'm being completely honest with you. But it can be, it's a useful habit to get into. So we have this equation here, this line here, and we want to find the equation of it. And I've drawn this horribly because, as you can see, it should be minus 5, so it should be going down. But it doesn't actually matter, it's a sketch. So what do you need for the equation of a line? Well, the equation of a line is y equals mx plus c, where c is the y-intercept, so where it crosses the y-axis, and m is the gradient. Now, how do you work out the gradient? Well, the gradient is just the difference in the y values. Over, so minus 5 minus 1, over 4 minus 2. That should be something you're fairly familiar with, but let me explain it a bit more. Just to refresh your memories, because it's summer holidays, your brains are probably rotten from all the Netflix and video games you're playing. All you need to do is take the difference in the y coordinates and divide it by the difference in the x coordinates. The gradient tells you how steep your line is. In other words, it tells you how much y increases or decreases by when you change x. And that's really important. In terms of which way round you have to do it, it doesn't matter as long as you're consistent. So what do I mean by that? Well, in this case, can you see that I've started with the coordinates here, so minus 5 minus 1, 4 minus 2. But I'd get the same answer if I did 1 minus 5 over 2 minus 4. But what you can't do is do, let's say, minus 5 minus 1 and then 2 minus 4. That isn't correct. You need to decide which coordinate you're going to put in front of which. We can use a calculator because all of A-level maths is calculator based, but I'm kind of hoping we don't need a calculator for this. Minus 3. Cool, now how do I work out plus c? Well, in my opinion, the best way is to just write the equation out again, but with m in place. And all we need to do is substitute one of these two coordinates into the equation to find out what c is. I'm liking the look of this one because it's small numbers, but also they're positive. So x equals 1 and y equals 2. So we have 2 equals minus 3, 1, hang on, that's the wrong way around. X equals 2, y equals 1. So then we have 1 is equal to minus 3 times 2 plus c. So 1 is equal to minus 6 plus c, plus 6 to both sides, and we get c is equal to 7. So our actual equation of the line is minus 3x plus 7 as our final answer. Pretty good, pretty easy, and again for 3 marks, that's actually not too bad. And here's another style of question that they can give you. So what they can also do is give you 2 equations and ask you, are they parallel, perpendicular, or neither? Now, this is a pretty interesting question. I'm going to go over it again, but likewise, it is similar to what you've done in GCSE. So, when 2 lines are parallel, it means their gradients are the same. Simple as, really. And how do you tell what the gradient of a line is? You need to put it in the form y equals mx plus c. This is the critical thing that students forget. In GCSE and in A-level, it needs to be arranged in this form. There's nothing in front of y. So it's not minus y equals mx plus c. It's not 2y. It's not half y. Nothing. It's y equals mx plus c. So if I look at this equation here, I can't say the gradient is 2 because the gradient isn't 2. It's not in the form y equals mx plus c. If you're struggling with what I mean by the form y equals mx plus c, y has to be by itself on one side of the equation. That's it. Okay? Now what about perpendicular? Perpendicular is a bit more interesting. It means the gradients multiply to minus 1. The other way to look at that is that they're negative reciprocals of each other. So for example, if you had one gradient was equal to, let's say, 2, and the other gradient was equal to minus a half, can you see that they're negative reciprocals of each other? Minus 1 over 2 would give me minus 1 over 2. Likewise, if I multiply them, again, you can use a calculator to prove it, it gives me minus 1. So those would be perpendicular. And what about neither? Well, neither is just neither, right? They don't have any relationship with each other. So one could be 2 and the other could be 3 or something like that. So, what do you have to do in this question? It's 4 marks, pretty beefy. Well, the first thing we need to do, or one of the things we need to do, the order doesn't matter, is put this in the form y equals mx plus c. The second thing, or the other thing we need to do, is work out the equation of the line L2. I prefer to start with the easy bit so I can secure some early marks. If you remember from the first part, it was 3 marks to just find an equation for L. This is 4 marks because you also get a mark for rearranging this equation. Pretty nice. So I'm going to start with L1. We have 2x plus 3y plus 5 equals 0. So I'm going to move everything that isn't y to the right hand side. And I'm going to do that because I want to keep y positive. But if you want to move y instead and then divide by minus 3, that's also fine. It's a free country, you can do what you want. So minusing 2x and minusing 5 would give me 3y is equal to minus 2x minus 5. And then dividing both sides by 3 would give me minus 2 over 3x minus 5 over 3. Now realistically we don't care about the y-intercept, but may as well have it. L2, again we're looking back at our first question and repeating the same process. We're going to work out the gradient and then sub in a coordinate to work out the y-intercept. So first of all, let's start with the gradient. So change in y over change in x. So the y coordinates here are 1 and 7. So I'm going to take this to be the one we start with. So 1 minus 7 over 5 minus 1. So that equals 1 minus 7 is minus 6 over 4, which is the same as just me saying minus 3 over 2. Now here's where things get a bit more interesting. Technically speaking, I don't need to work out the rest of the equation of the line. Technically. So I can get a mark for this, and a mark for working out the gradients. Let's just tick them. 1, 2. Then by showing something, I can get the last 2 marks. So you don't technically need to work out the full equation of a line. But if you do, you can secure another method mark. So I can jump straight to the answer now, and if I'm right, I get 2 marks. I get 4 marks in total. Okay? However, if I'm wrong, I get 0. So doing the extra step of working out the equation of the line can get you a free mark no matter if you're right or wrong. That's just some exam technique I'm trying to kind of hand your way. That's why doing the extra steps, even though it may be a bit tedious, sometimes is a good idea just to secure extra marks. Okay? So for the purposes of this, let's go through what the equation of the line would be. However, if you want, you don't have to do this step. So minus 3 over 2x plus c. Subbing a coordinate, let's take the first one, so 1 and 7. So x equals 1 and y equals 7. So we get 7 equals minus 3 over 2 times 1 plus c. So I'm going to move this over to the other side, and this is where I'm going to use a calculator because I'm going to be a bit lazy. So pull up our calculators. and we have 7, and now instead of minus it's plus, plus basically 3 over 2 times 1, but I'm going to write out the full thing again just to make it super transparent, 17 over 2. So our equation is minus 3 over 2x plus 17 over 2. Now if we compare the gradients, so the gradient of m1 was minus 2 over 3, and the gradient of line 2 is minus 3 over 2. Are either of these true? Well, they're not the same, so they're not parallel. Cool. Do they multiply to give minus 1? Well, I can see that they're not negative reciprocals of each other. So the answer would be neither. Okay. But if you want, if you want to go a bit deeper, you can say things like gradients not equal, therefore not parallel. Then you could also say gradients are not negative reciprocals. I promise I can spell. Reciprocals, therefore not perpendicular. If you want, but you don't really need that last step. Hopefully that makes a bit more sense. Before we go on to the next question, I do want to just make yourself aware that if you go over to that Patreon, there is an actual A-level mechanics course, mechanics and statistics course. So as you guys may know, you have 3 papers in your A-level maths, paper 1, 2 and 3. 1 and 2 are so-called pure content, which is something that I'm going to cover all on YouTube completely for free. However, paper 3 is your applied content, which is mechanics and statistics. And schools don't always cover this completely or even at all. So I decided to make a really in-depth course, which is currently being updated and uploaded on Patreon now for about £10 per month. Okay, so it has these types of videos, it has worksheets, it has mark schemes, and it's going to have also a direct line to me that you can talk to me about. I also have opened up the booking for A-level maths tuition classes. My email's in the description, so just email me if you're interested and I can give you a few more details for that. Okay, so with this question, we have find an equation of the line passing through these 2 points, and we have a new form. So it's not really new, but it's the form that they've given this line in here. And it's a pretty common thing. And this is another place where students lose marks, because they will find the equation in this form and leave it. If you don't put it in the form they ask for, whether it's y equals mx plus c, whether it's ax plus by plus c, then you drop a mark. It's a free mark. Please rearrange your equations, okay? And afterwards it says the area of a triangle AOB. Just like I said, you're going to have some geometry. Sometimes they even put parallelograms and stuff. Crazy, I know. This is where diagrams are going to be useful. For part A, we don't need a diagram. We just need to do the same thing we've been doing before. Find the gradient, find the y-intercept, and then the last step is to rearrange. Nice and easy. So, we have, also, I'm actually going to show you a way, there's another way of working out the equation of a line, where you can get it in this form really easily. And you may have seen this equation before, but I'm going to show you in literally 2 seconds once we've done the gradient. So again, I start with this one, so minus 1, minus 5, because those are the y coordinates, over 5 minus minus 2. So don't forget, it is the difference in the numbers. So it's not just 5 minus 2, because between minus 2 and 5, there's 7 digits, not 3 digits. So, minus 1 minus 5 is minus 6. 5 minus minus 2 is, of course, 7. So, once you've got this, what is this alternate form I'm talking about? So, what you can do, if you really like, is work out the equation of a line like this, and then times it and do all that fun stuff. However, I want to show you an alternate method. If you want, use your normal method. We'll get the same answer. It's completely fine. But I want you to be aware of the alternate method in case it's useful to you. You can also use this as your equation of a line. And it makes it sometimes slightly quicker to get into this form. All this is you just sub in a coordinate. Minus 2 and 5 or 5 minus 1 doesn't make a difference, okay? Which is pretty cool. It will work out right either way. Choose whatever coordinate you want. So let's say we use the first coordinate here. So y1 is of course just the y coordinate. So y minus 5 equals m, which is minus 6 over 7. X, and then it says minus x1. but it's already minus 2, right? So it's minus minus 2, so in other words, it's plus 2. Then from here, I can see that it's going to be over 7, because in this form here, ax plus by plus c, they're all integers, which means there's no fractions. So to get rid of the fraction here, I'm just going to times everything by 7, because what that's going to do is eliminate every fraction we'll ever get in this equation. And that's another benefit. Sometimes with this equation here, you get 2 different denominators. You might get 2 and 3, which means you have to times by 6 to get rid of it. But sometimes it's not as simple as that. Okay? Whereas with this one, you know what the denominator is going to be, and you can just times through. So y minus 5 equals minus 6 x plus 2. Whoops. Expand the brackets. So y minus 5 equals minus 6x minus 12. Then all you have to do, the last step, I just realised I didn't times the left hand side by 7. That was a rookie mistake. 7y minus 35. 7y minus 35. The last thing you need to do is just move this stuff to the left hand side. So we're going to add to both sides 6x plus 12. So we have 7y, that stays the same. Then it says to do the x's first, so that would be 6x in front. And then we have minus 35 add 12, which of course is minus 23 equals 0. So I don't have to faff around with all of the fractions. It just gets rid of them for me. And it's really quick and easy. So that's just an alternate method if you want. But again, using this normal formula, this normal one that you've got from GCSE, is completely fine as well. Okay, so now we have something a bit more interesting. It then says, this line that we've just worked out here crosses the x-axis at point A and the y-axis at point B. O is of course the origin. Find the area of the triangle AOB. Well, let's have a look at this. I can tell that we're going to have a roughly straight line. Okay. Now if I look at this line here, I can see that as the x gets more positive, y goes down. So in other words, the y-intercept is here and the x-intercept is there because it's a line going downwards. And I can see that from here, right? As it goes to the right, y is going down. So as it goes to the right, the line's going down. Okay? Of course, this is the origin. Remember, this makes a right angle because the axes are always perpendicular to each other. So, point B is the y-intercept, so let's put B there. And A is the x-intercept. So all we need to do now is work out the x and y-intercept of this equation. Now, to be honest, y equals mx plus c would be the better form in this case, but we don't have that in this case. So let's sub in x equals 0 for the y-intercept, x equals 0. So that gives me 6 times 0, which is 0. Then we have 7y minus 23, 0. 7y equals 23. Y is equal to 23 over 7. What a beautiful number that is, but let's put it on there anyway. Also, we do have that's the area of that's the triangle we're trying to work out. Then for the x-intercept, we sub in y equals 0. So remember, this is the y-int. This is going to be the x-intercept. Okay, so for the y-intercept, you make x 0. For the x-intercept, you make y 0. So you have 6x plus 7 times 0, so that's 0. So minus 23 equals 0. 6x equals 23. X equals 23 over 6. So that's going to be over 6, like that. Now it shows the area. Well, that's fine. How do you work out the area of a triangle, a right angle triangle? All you have to do is you do half base times height. So a half. What's the base? Well, the base is the length of this line. Well, if we think about it, this is the origin here. So that's at 0. So it's from 0 to 23 over 6. So that length is 23 over 6 because it goes from 0 to 23 over 6. I said that a lot now. And then we have the height, which is going to be 23 over 7 because it starts at 0, ends up at 23 over 7. So the height is indeedly 23 over 7. Now let's just sub it into our handy dandy calculator. A half, 23 over 6, 23 over, Oh, that was tragic, wasn't it? Half over. So all we need to do is sub it into our calculator. So all we need to do here is we need to do a half. So 1 over 2. 23 over 6. That's not 6. Close bracket. Open bracket. 23 over 7. And that is going to be our area of the triangle. Let's do it as a decimal. 6.30 to 3 sig fig. And then 3SF. And what are our units going to be? Well, if they don't give you a unit, which they don't in this case, then it's just going to be units squared. So whether this is meters, kilometers, miles, inches, whatever, it's correct. Here is another style of question that they can ask you. I know there's a bunch of different ones. So in this case, we have points A and B have coordinates -1k plus 2 and 2k minus 3, 8, where k is a constant. Given that the gradient is a third, show that k equals 4. So once again, I want to bring up the kind of exam technique I kept hammering into you during the GCSEs, but also in the previous videos, is that A, they have to give you enough information to finish the question, and B, they don't give you useless information. So if I just look at this top piece, they've given me everything I need to know in these 2 lines. They've given me the coordinates, and they said that given the gradient is this. So we have to use the fact that the gradient is this to work out this. How do we do that? Well, we write what the gradient is in terms of a mathematical equation. How would we work out the gradient of AB? We'd do the difference in y over the difference in x. Let's do that. So we have 8 minus k plus 2, but be really bloody careful. It's not 8 minus k plus 2. It's not that. Think about it. You're subtracting the whole thing. That 2 is going to become negative because you're subtracting it. So very, very sly, very, very easy mistake to make. Then we have 2k minus 3 minus minus 1. So that, it doesn't really require brackets, but you know, I'm nothing if not consistent. So here what we're going to have minus k, if we expand those brackets. Then we're going to have 8 minus 2, which is 6. Although it looks like a b. Then we have 2k minus 3 plus 1, so that's 2k minus 2. And what does that equal? That equals a third. So now we do a little trick that we did back in GCSEs where we cross multiply. What that means is we bring 3 up to the top over there and the 2k minus 2 over there. So it becomes 3 minus k plus 6 equals 1 2k minus 2. Expand and simplify. So we have minus 3k plus 18 equals 2k minus 2. Bring all the k's to one side, so it'll probably be easiest to add 3k to both sides to keep everything positive. So we have 18 equals 5k minus 2. Plus 2 to both sides, we get 20 equals 5k. And then we have k is equal to 4, which is exactly what the question's telling me to do. Cool. For part B, just in the interest of saving some space, let's do it next to the question. Find the equation of the line that passed through A and B. Well, we have the gradient. So we can immediately write y is equal to a third x plus c. Because remember this magical equation, mx plus c. All we need to do is find out what c is. And we can do that by just subbing in a coordinate. So remember, k is equal to 4. So this coordinate here is minus 1, 4 plus 2, which is 6. Okay? So x is equal to minus 1 and y is equal to 6. So we have 6 is equal to a third times minus 1 plus c. So we have 6 is equal to minus a third plus c. So c is equal to 6 plus a third. It's 6.3 recurring, but because I'm lazy, let's do 6 plus a third. 19 over 3. So that was a very generous question right there. However, don't fall into the trap of trying to work out the same bloody thing again. Now it doesn't. What I want to do now is check if the question says what form I should give it in, and it doesn't. Which means you can leave it as y equals mx plus c. You can leave it as ax plus by plus c equals 0. You can also leave it in this form here. Pretty interesting. So why did I choose y equals mx plus c? Well, I have to admit, I did cheat a bit. I saw what the next question was. Okay, I know it's not exactly fair, but using this is going to be a lot easier, in my opinion. It's asking me to work out the equation of something called a perpendicular bisector. That's really fancy words for something that isn't that bad. Perpendicular means 90 degrees. What does it mean to bisect something? It means to cut something into two even pieces. So what does it mean? It means it's a line that cuts another line in half at 90 degrees. So if I were to draw this, and again, I hope that you'll give me some sympathy here, because as you know, my drawings are not the best. This would be our coordinate A and our coordinate B. It might be worth actually working out what the coordinates are. So this first one is minus, so A is -1 and 6. And coordinate B will be 2k minus 3. So if k is 4, that's 2 times 4, which is 8, minus 3 is 5, so 5, 8. Then we're going to have another line doing something like this. That's not bad. At 90 degrees, but it's going to go through something called the midpoint. So we have to work out what the midpoint of AB is. Not too bad. Again, drawing diagrams can really help you. So if they ever ask you to work out a perpendicular bisector, here's a few things you need to know. You need to work out the midpoint of the line. Then you need to work out the gradient of that line, which we already have. Then you just need to work out the equation of the perpendicular line. So let's do it. Midpoint. How do I work out the midpoint of AB? Well, that is just going to be, here's how I do it personally. I add the x coordinates together and divide them by 2. Remember, we're trying to find the number between -1 and 5 and the number between 6 and 8. And there's a few ways to do that. One way is to just eyeball it. Between -1 and 5, that would be 3. And between 6 and 8 is, of course, 7. And that is the correct answer. But if you're unsure, here's what you should do. You should add the coordinates together. So -1 plus 5. Sorry, not 3. 2. And divide it by 2. And the next one is 6 plus 8 over 2. And if you work those out, -1 plus 5 gives you 4. 6 plus 8 gives you 14. Which, as you can see, simplifies to what we already had anyway. So you can eyeball it, but there's also an equation here for you. And realistically, it's not an equation you need to memorize per se. It's just, finding the middle of two numbers, you add them and divide them by 2. It's kind of a fact. It's just finding the mean, actually. So we have that. Let's get rid of that to give us some space. Now the gradient of AB, which I'm going to do as a lowercase m, because that's not confusing at all, is it? Is a third, which means the gradient of the perpendicular line is the negative reciprocal. So if I flip that fraction, I get 3 over 1, and then I make it the opposite sign. So in other words, it's -3. So my equation for the perpendicular line, let's call it LP, is y equals -3x plus c. But I now have a handy dandy coordinate I can just substrate in to work out what c is. Cool. Also, I know what you're thinking. It's ax plus by plus c. So why don't I use the handy dandy shortcut that I gave you earlier? Here. I just wanted to show you both ways. That's the only reason. So x is equal to 2. Y is equal to 7. So we have 7 equals -3 times 2 plus c. So 7 equals -6 plus c. C is equal to 13. So my equation is y equals -3x plus 13. But we want ax plus by plus c. So we're going to move all of that to the left-hand side. So 3x plus y minus 13 equals 0. So all I did is I added 3x and I minus 13 from both sides. And that is your final answer. Hopefully not too shabby. 4 marks. I think it's pretty generous, especially if you draw a diagram, just so your brain knows what you're trying to do. I think that's pretty okay. another thing they can ask you to do is find distances between points. And there is kind of a slight caveat to this, because before I showed you working out the area of a triangle and it's very, very easy. And working out these lengths was also really bloody easy. This gets ever so slightly harder because they might ask you or expect you to be able to use the sine or cosine rule and also the half AB sine C formula in these coordinate problems. And the reason why that's a bit harder is because you need to potentially work out lengths of triangles that are, instead of being kind of right angle triangles, they may be something like this, just in the middle of a coordinate series, just in the middle of a graph somewhere. And that's where it gets a bit trickier. So one of the formulas you'll need to do is actually work out distances, which is really, really important. So yeah, it does get slightly harder, and when we come on to do the sine and cosine rule again, I'm going to include some of those questions in the coordinate geometry section of it. But for now, all we need to do is read this question. So it tells me that, first of all, I want to draw my axes, that we have an equation, 2x minus 3y, 2x minus 3y plus 24 equals 0. And they meet the coordinate axes of the point A and B. Find the distance of the midpoint of AB from the origin. Give your answer in the form k root 13. Okay, that's a pretty involved question. So I'm just going to make the executive decision to make A over here and B over here. So if I draw a line joining those 2 points, they're asking me to work out the midpoint and then work out the distance from the origin. It's quite a few different things, right? But it isn't as bad as it may sound. Here's what you do. By the way, this was a 6-mark question. Okay. First of all, let's take it step by step. We need to work out the x and y intercepts. I'll start with that. That's easy. So if we start with the x-intercept, that is where y is going to equal 0. So that means we have 2x, then minus 3 times 0, so I'm not even going to bother putting it, plus 24 equals 0. So 2x equals minus 24, so x equals minus 12. So you might think, well, that means your kind of coordinates, your diagram is wrong. And you'd be 100% right. You'd be 100% right. But it doesn't actually matter. If you want, you could redraw this. And you can put b minus 12, you can put it on the other side here. Completely fine. The diagram is not there to be an accurate representation of what this looks like, so you can draw, like, measure it with a ruler. The point is to make sense in your brain what you have to do. So, I'm going to leave it like this, but I'll also draw what it should look like as well. But I'm going to do that after we work out the y-intercept as well, just so we know it. That is when x equals 0 for the y-intercept. So we have minus 3y plus 24 equals 0. You can move the 24 over, you can move the minus 3y, completely up to you. So then y is equal to 8. So it looks like my a is completely and utterly fine. By the way, I haven't bothered putting the comma 0 or putting the 0 before the 8 because since we're working out midpoint, it doesn't matter. But if you'd like, just to make it super transparent, we can put the 0 here and we can put this as 0, 8. So point A was fine. However, if you really wanted to, you can move A to where it should be over here. Not A, sorry. Point B. If you want. Okay, but you're actually going to get the exact same answer anyway. So, after we've got that, we need to now find the midpoint of those two coordinates. And how do we find the midpoint? Well, we have two options. Because they're intercepts, you can probably eyeball it quite reasonably. So what's midway between 0 and minus 12? Minus 6. And what's midway between 8 and 0? 4. However, again, I'm going to just prove it to you. If we add the x-coordinates together, that will give us the x-coordinates. We have 0 plus minus 12 over 2 does indeed give me minus 6 for our x-coordinate. And changing the top numbers to the y values, we have 8 plus 0. So either way, whichever way around you do it, you're going to get that answer. And now we need to find the distance of the midpoint, point M, from the origin. Now, how do we change this into a distance? this is where things get a bit more interesting. And it's going to get interesting because I'm going to use a different colour. So let's use red because it's the colour of danger. And I'm going to draw a nice little triangle over here. You might think, why on earth are you drawing a triangle, you madman? Well, if I draw this triangle now, if I'm working out that distance, that's just the hypotenuse of a right-angled triangle, isn't it? And what would the base of this triangle be? Well, it's going to be the x-coordinate, isn't it? As a length, right? So I don't actually need to put the -6 because it's a length. And even if I did put the negative, we're going to square it away regardless. Because again, this is the origin and this is the midpoint. So all you do is you take the difference between one point, the first point, and the second point. The difference in the x-coordinates is 6 for this one, okay? If this number was 1 over here, the difference would be 7, right? 1 minus 6. Whatever way around you like to do it. And then the height, again, we take the difference in the y-coordinates. From 0 to 4, that's a difference of 4. So now the distance of the midpoint from the origin is simply Pythagoras' theorem. Square root 6 squared plus 4 squared. Now because it says give it in terms of surds, we might want to do this by ourselves. So 6 squared is of course 36, 4 squared is 16. So that's going to be the square root of 52. And we want it in terms of 13. So how can we do that? Well, 36 times 4, 13 times 4 gives me 52. So I can change this into square root 4, square root 13. So in other words, it's 2 root 13. So k is equal to 2 as our final answer. So I hope that makes sense in terms of working out the distance between two coordinates. But just in case it doesn't, I'm going to give you another example. Let's say we have 2 points, A and B. Coordinates of this one are simply 1 and 3. Coordinates of this one are 6 and 8. What is the distance? Well, once again, we're going to draw out our little triangle. What is the difference in the x-coordinates? Well, it goes from 1 to 6, so that would be a difference of 5. This goes from 3 to 8, that's also a difference of 5. So you do the same thing again. 5 squared plus 5 squared. Okay? Just work out the difference first. The reason why I'm telling you to do this is because there's some formulas online which look a bit complicated. So the technical formula is this. I don't know about you, but that's a pretty hideous formula, isn't it? Whereas all it's saying is take the difference of x and square it, which is what we did. Take the difference of y and square it. That's what we did. So I prefer the way of just working out the difference in the coordinates in my head. And for the final question that we're going to go through today, there are 2 new parts, which is this thing here and this thing here. Okay? But not to be afraid. First part should be super easy. Have a go yourself. Have a go in your head if you want to. It tells me the gradient and it tells me what it passes through. Y equals mx plus c. Look at that. They give me everything. So if y is equal to 3x plus c, x is equal to minus 2 because of the coordinate, y equals 5, sub it in, and that gives us minus 6 plus c, and c is equal to 11. So our final answer is just 3x plus 11. Wonderful. Intellectually stimulating. Okay. Part B is a new type of question. Because what they tell you is line L2 is perpendicular to L1, passes through 0, 4. So once again, y equals mx plus c. Now if it's perpendicular, its gradient is going to be the negative reciprocal. So 1 over 3, make it negative. And now you sub in this coordinate, right? Well, you can, and you'll get the right answer, don't worry. But if the x-coordinate is ever 0, that is the y-intercept. So my answer, whether you sub it in or not, is just this. Look at that. Not too bad. Look at that. 4 marks in how many minutes? 2? 1 minute and 38 seconds according to my recorder. 1 minute 38 seconds for 4 marks. Pretty good. So for part C, it then says find the coordinates where they intersect. And this is the other new part. You may have done this in GCSE, but it's kind of a grade 8, 9 type topic. So it might be a slightly harder. So let's have a thinky poos. When they intersect, their x and y coordinates are the exact same. So all we need to do is equate this equation with this equation. So I'm basically subbing in y into here. So we have 3x plus 11 equals minus a third x plus 4. So can you see I've just equated the two equations. Whenever they intersect, whenever two equations intersect, whenever the two lines, curves, whatever intersect, you can equate their equations whenever they intersect. Okay? It's a really, really useful thing for a lot of A-level maths. Bring the x's to one side, so I'm going to plus a third x to both sides. So that's going to be 3 plus a third, so that's going to be 10 over 3x. Plus 11 equals 4. Minus 11 from both sides. We get 10 over 3x equals minus 7. Times both sides by 3, yeah. 10x equals minus 21. Divide both sides by 10, we get minus 21 over 10. That's my x coordinate. By the way, linear graphs will only ever intersect once at max. So now we have that, are we done? No, because it says find the coordinates. You need to have the y coordinate. Now, does it matter which equation I sub in x? No. I'm going to just sub it into this one because I feel like it. That is literally the only thought process I've put into this. It doesn't make a difference because, again, x and y are the same at this point of intersection. The coordinate is the same. And then I would just use a calculator. Laziness is amazing. We're going to have minus, so I've got to put 3, minus 21 over 10. Then we're going to have a plus 11, 47 over 10. And then just for added brownie points with the examiner or my teacher, I would say I'd literally write out what the coordinate is separately, like that. And then again, with a good old-fashioned box around it, that should make it simple. So, once again, the worksheet is on Patreon. Check it out and do these questions again in a day or two to make sure you retain it. It will help your long-term memory. Once again, check the Patreon for the Statistics and Mechanics course. See if you like it, see if you want to contribute to that. And lastly, if the tuition classes are open for booking, so email me if you are interested. The email is in the description, and so is the A-Level Maths playlist from last year. I hope you all have a wonderful day.